In this video, I'm going to talk about what to do when you first get your data. There's no hard and fast rules, but the first thing I would recommend is never start with the model, start just looking at your data. So that's what this notebook is about. You have access to the OR files. I'm going to work through the PDF, which has the OR information. So as always, the first thing is just reading the data. Yeah. Then have a look at the summary statistics. It's a first just quick peruse. You kind of get a feel what's in the data. Are there continuous variables? Are there categorical variables? Are there some variables that might not have loaded appropriately? That is what you're looking for, the summary statistics. You can then, from that point, so here, this is an extension of the data you would have seen in probability and statistical inference. We have age, we have sex, male, female, we have height, which is a range, reaction time, once again, continuous variable. I've included age group, eye color, so we have 4 eye colors here, income, BMI, weight, and swimming distance. So maybe I have a hypothesis beforehand about what I want to look at, but it's good to look at the variables by themselves. So I do a histogram, hist of the age. Here we see a flat age distribution, which is fine. And the age goes from 20 to 70, nothing too interesting in that. Then I have a look reaction time. Now, reaction time generally is skewed, but here we see that it has a nice bell shape. It looks symmetric. I'm happy with that. That's important because when we feed our data into our model, if it isn't symmetric, isn't in this form, our model will have a problem with it, and one of the assumptions of our model would be violated, be a linear or even a logistic regression. Then I have a look at BMI. That's also looks nice, normally distributed, so I wouldn't worry too much about it. Now, income. Income is skewed. I can look at the skew values, but I can see it in the figure. There's a long tail to income. There's no surprise, as we've seen recently. 10 people are in the billion category, 100 billion category, and they're skewing income. Now, we can talk about what you might do with that. You could actually just go, get rid of that 1%, and that'll normalize our data, or we can do transformations to our data. Yeah? So there are different transformations. The classic one is just take the log of the data, the square root of the data, or you square the data. Here, I'm just going to take the log of the data. It didn't help. Yeah. So then I do the square of the data. That really didn't help of the income. And then the last thing is I do the square root of the data. Now, what should I use? What's my informant? So log, square root, square. Generally, you should look what people have done before with that kind of data. And so see how people have addressed that kind of shape. Sometimes you don't have to do it. Sometimes you do have to do it. It's just something to be wary of. Now, in the end, income probably isn't going to contribute to our model, but it's good to know that you can do something with it such that it can be normal and can contribute to the model. Yeah? Another way of looking at it, instead of using histograms, are box plots. Okay. So with a box plot, what you have is you have your mean, you have your 50% range. So this is for age. And then you have your tails. Yeah. Now, age was very nicely normally distributed. And you see that there's nothing funny about this. The mean is in the middle of the 50%, everything's fine. Now, reaction time, you see here these little dots, that's some outliers, people who are quite slow and people who are quite fast. Yeah? So a box plot can help you identify outliers. Yeah? There are 3 standard deviations beyond. And so you could go, okay, maybe I need to look at those data. Maybe there's something funny about those data. Similarly with BMI, we have some more outliers, some very low, some very high. But overall, that data looks normally distributed. So maybe I wouldn't worry so much about the outliers because they're not single entities. Sometimes you'll see like a person by himself all the way up there, and then you know that that is a true outlier. And you have to investigate. Here, it's more apparent. You have that outlier there, John Delaney, sitting there on his wage, who's an outlier from everyone else in Ireland. Now, the mean isn't that off center, but you see these 10, 20 people are just skewing the income up. Now, that is justifiable to say, actually, we can exclude those 10 people, it'll sort our data. But you know, you need to be very upfront and open for why you did it. Looking at the normalized data as we did there, taking the log transform, it looks okay. And that's why you have to look at both the histogram and the box plots. Square data, you see these outliers, but the square root data looks okay here. But as we saw with the histogram, it was actually quite nice and normal. Now, just be very careful. There are some, for example, is a 0 really a 0? Is that a mistake? Should it be in there? All these things you have to consider. And that's why you need to dig into your data to find out, is there outliers that are worth getting rid of? Or is the outlier just part of a continuum and it's just a small bit above? Or is it truly, like in these cases, like John Delaney being miles away from everyone else and it being an obvious outlier? Yeah. There are many ways of doing this. It isn't art for a lot of time for this. So there is an iterative nature to it. You draw, you plot, you come back, you think about it more, you look more at it. So, you know, thinking about this initial analysis, it's quite time consuming because you have to make a lot of figures. A lot of those figures won't go into your final report, but it gives you a feeling for what's happening in the data. And that's of vital importance.